1. In all of Module 6, we're going to take a look at reactions, specifically synthesis, decomposition, and combustion. Before we learn about those types of reactions, we have to understand the different types of equations as well as balancing them. So as you might remember from grade 10, if you are given a reaction like this, an equation like this, where you have the names of each of the compounds written in a chemical equation format, this is what we call a word equation. Okay, so no chemical formulas, only the name. Another thing that you might see is the skeleton equation. So these are the chemical formulas of each of the chemicals involved. However, these reactions, skeleton equations, are not balanced. So taking it a step further, a balanced chemical equation includes coefficients to designate the number of chemical formulas for each compound. So if you take a look here, in this skeleton equation, there is no coefficient. So whenever you don't see a coefficient, you can assume that it has the number 1 here. So the big numbers involved in balancing chemical equations are called the coefficient. The small numbers, we've already learned about them when writing chemical formulas, are called the subscripts. Now, as a rule, you never change the subscripts when you are balancing an equation. The only number that you can change are the coefficients. So what you want to do is change the coefficients such that each element on the left side and on the right side correspond to the same number. So let's take a look at potassium here. So potassium is the element K. There are 2 potassiums on this side. How do I know that? I don't see a coefficient, so I'm going to multiply whatever subscript I have by 1. So there are 2 elements of potassium on the left side of this arrow. On the right side of this arrow, I already have a coefficient of 2, which means that there are 2 potassiums on the right side. If you take a look at each of the elements that you see on the left versus the right side of the arrow, you know that this is a balanced equation, because whatever the number is of the element on the left side, there would be the same number of that element on the right side. Okay, so let's get used to starting with the word equation, writing the skeleton equation, and then balancing it as well. So if I'm given the word equation, all I would have to do is write the chemical formulas for all of the compounds that I see. So iron 3 nitrate is FeNO3 3 plus ammonium hydroxide is NH4OH. So this involves you being very familiar with our chemical nomenclature module and being very quick and very fast at writing the chemical formula if you're given a name. So iron 3 hydroxide is FeOH3 plus NH4NO3. So this is my skeleton equation. They're all chemical formulas, but they're not balanced. Now let's balance this out. If I was going to write my balanced equation, so first I would need to have all of my chemical formulas. So NH4OH gives you FeOH3 plus NH4NO3. So let's start by balancing this question. I'm going to pick a different color pen. I've got 1 Fe on the left side and 1 Fe on the right side. So how do I know that that's 1? I don't see a subscript, which I'm going to imply means that there's 1 of that element. I don't see a coefficient, which means that there's going to be 1 of that element there as well. So just like that. So one Fe, one Fe. So I'm good to move on to another, to the next element that I see. Now the next element that I see is not just nitrogen, but NO3. And if I see NO3 on the left side of the arrow, and I see NO3 on the right side of the arrow, I'm good to just clump those together. So on my left side of the arrow, I've got 3 ions of NO3, right? So for every NO3, there's 3 of them. That's what this 3 represents. And on this side, there's only 1 NO3. So I need to change the coefficient here such that there are 3 NO3s here, just as there are 3 NO3s on the left sides. So having changed that, let's move on to ammonium, which is NH4. I've got 1 NH4 on the left side. And on the right side of my arrow, just because I've put in the 3 here, I've got 3 NH4s. So I've got 3 here and 1 here. I'm going to add a coefficient of 3 so that there are 3 here as well. Moving on, the last polyatomic ion that I have left over is OH, and I see OH on the left side, OH on the right side. OH on the left side, there are 3 of them. OH on the right side, also there are 3. So now this equation is completely balanced because each element on the left side and on the right side are equal to each other. There is the same number of each element on the left and right side. Okay, so this is a question that's describing a reaction. What we have to do is write the word equation, the chemical equation, as well as, so the word equation, the skeleton equation, as well as the balanced equation. So dinitrogen pentoxide gas in the presence of a platinum catalyst and high enough temperature forms nitrogen gas and oxygen gas. Okay, so if I was to write the word equation for this, I know that we're talking about dinitrogen pentoxide. Right? It tells you that in the right conditions, so with the presence of a catalyst as well as with enough temperature, it produces nitrogen gas plus oxygen gas. There we go. So this is what I would call the word equation. All right. Next, I can write my skeleton equation. So skeleton equation only includes the chemical formula of each of these compounds, but not balanced. So skeleton equation. So dinitrogen pentoxide, this is a molecular compound because it has the prefixes. So dinitrogen pentoxide, my arrow. Nitrogen gas, nitrogen is one of the diatomic elements. So that means that when it's by itself, it has a subscript of 2, plus oxygen gas, which is also a diatomic element. So when it's by itself, it has a subscript of 2. All right, moving on, we're going to go into the balanced equation next. So for the balanced equation, I need to start off by writing my skeleton equation and then going from there. So let me change the color of my pen. And I essentially, as I mentioned earlier, want the same number of elements on the left side of the arrow as I do on the right side. So N2, there's 2 nitrogens on the left side, 2 nitrogens on the right side. In terms of oxygen, I've got 5 oxygens here and 2 oxygens here. And when I have a situation where on the left side I've got 2 very different numbers, what I can do is multiply them by each other. So put in the coefficient here of 2 and put in the coefficient here of 5. So if I take a look at the number of oxygens, I've got 10 oxygens here and 10 oxygens here. Now that does change the number of nitrogens that I have, but that's okay because 2 times 2 is 4, and I could easily put a coefficient of 2 such that the number of nitrogens also is 4 on the right side. So now this is the balanced equation for this particular equation. Now moving on, something that you will see with a balanced chemical equation are states. And you might have learned this in grade 10, you might not have, but for any chemical compound that we know to be a solid, right beside that chemical, you would write a small bracket with an S inside of it. For example, if you're writing iron, you'd have bracket S. If you have NaCl, which is a solid, brackets S. If it's a liquid, you would have the same brackets, but instead of S, you would have the letter L, which means liquid. For gases, same thing, except the letter inside is going to be a G. Now the last one means aqueous. Aqueous tells you that that particular substance has been dissolved in water. So a salt solution, so NaCl, even though it could exist as a solid, if it is dissolved in water, and that's the solution we're talking about, we would designate it as aqueous, which means NaCl has been dissolved in water. Similarly, with ammonia solution, ammonia has been dissolved in water, which is why we write AQ. Now here's a few more equations for balancing. So if you want to take a second, pause the video and see if you can balance these out, and then play the video to check to see if your answers are correct. So in the first example, I've got barium, 1 barium on the left side, 1 barium on the right side, 2 chlorines on the left side, and 1 chlorine on the right side. So what I'm going to do to make this a 2, I'm going to write the coefficient of 2 in front of the NaCl. Now note that this 2 applies to not only the Cl, but also the Na. So I've got 2 Na on the right side, 2 Na on the left side. SO4, there's 1 SO4 on the left side, 1 SO4 on the right side. Now if I take a look, this is a balanced reaction. So 1 barium, 2 chlorines, 2 chlorines, 2 sodium, 1 sulfate, 1 sulfate. So this is a balanced equation. Now let's take a look here. So I've got 1 sodium and 2 sodium. So 1 sodium on the left, 2 on the right. So I'm going to put a coefficient of 2 in front of my Na. Now when I do that, that changes the number of all of these elements. So I've got 2 hydrogens. Let's take a look on the right side. I've got 2 hydrogens there as well. I've got 2 carbons. Now this one doesn't exist as 2 carbons together, but there's 1 carbon here and 1 carbon here. So 1 plus 1 means that we've got 2 carbons. And then oxygens, I've got 3 times 2, which is 6 oxygens. So I've got 3 oxygens here, 4, 5, 6. So having put the 2 here, this becomes a balanced reaction. All right, let's take a look at this last one. So NH3 plus CuO gives Cu plus N2 plus H2O. So right off the bat, I'm going to start with nitrogen. I've got 1 nitrogen on the left side, 2 nitrogens on the right side. So I'm going to put a coefficient of 2 here to balance the nitrogens out. That changes my number of hydrogens. So I've got 6 hydrogens here, but only 2 hydrogens here. So I'm going to put the number 3 here to try and balance that out. So 2 nitrogens, 6 hydrogens, both of those are balanced on the left and the right side. Let's take a look at the number of copper. I've got 1 copper here, 1 copper here. That's good. 1 oxygen here, but 3 oxygens on this side. That means that I have to put in a number of 3 on the left side. Having done that, that changes the number of copper that I had. So I've got 3 copper here, but only 1 here. In order to balance that out, I would put a coefficient of 3 So if I take a look, all of this is balanced. And that's it.